So now we're going to want to use these Pythagorean identities to simplify expressions. So for instance, we have this expression 1 minus cosine squared. So if I'm thinking back to my Pythagorean identities, I know that one of my identities is cosine squared of theta plus sine squared of theta equals 1. Can you picture how I might be able to manipulate this expression or this equation so that it has this expression as part of it? What if I took this equation and I subtracted cosine squared from both sides? If I did that, then on the right side of the equal sign, I would have 1 minus cosine squared of theta equals, over here, these are going to simplify to 0, leaving me with sine squared of theta. What this means is 1 minus cosine squared of theta equals sine squared of theta. Therefore, we've simplified this expression to sine squared of theta. This kind of points out to you, hopefully, that these expressions can be manipulated, right? If I wanted to, I could change this expression by, for instance, subtracting sine squared from each side. That means that cosine squared would equal 1 minus sine squared. Or on this example, I could take away tangent squared from each side. So 1 would equal secant squared of theta minus tangent squared. So these can all be manipulated and rewritten in certain ways to help you to simplify expressions. So let's look at the next one. Secant squared of x minus 1. Excuse me. So the x here could also be rewritten as with a theta. It just is up to you, whatever your angle is. We use theta here, but x's are fine as well. So secant squared of x minus 1, if I look back at this expression right here, this equation, if I want secant squared of x minus 1, well, hopefully you can see that if you were to take 1 away from both sides, then the expression that you would have on the right side of the equal sign, you would have secant squared of theta minus 1. And on the right side, you would still have tangent squared of theta. So that means secant squared of x minus 1 is equal to tangent squared of x. Let's look at number 3. 1 minus cosine squared of x. You might not feel like you have to write it all out, but I'm again just going to write down the expression that we have on the other page. So cotangent squared of x plus 1 equals cosecant squared. So this is going to be the expression that I'm going to have to use in order to manipulate this. So 1 minus cosecant squared of x. Well, it's not going to work to take away 1 from each side because I don't want cosecant squared minus 1. I want 1 minus cosecant squared. So what if we subtract cosecant squared of x from both sides? So right now you would have the cotangent squared of x plus 1 minus cosecant squared of x. And I just want this part left on this side, so I'm going to actually take away cotangent squared of x. So that means 1 minus cosecant squared of x, which is our expression, is actually going to equal the negative cotangent squared of x. So what happens if we have an expression like this? 8 cosine squared of theta plus 8 sine squared of theta. If I look at this, it's probably not going to stand out quite as much as maybe some of these did, because these were really just taking our Pythagorean identities and solving for different parts of them. But on something like number 4, you might have to try something new. So for instance, I can see that each of these terms has an 8. So what if we took that 8 and we factored it out? So if I factor an 8 out of the first term here, I would still have cosine squared of theta. And if I factor 8 out of the second term, I would still have sine squared of theta. So we have 8 times cosine squared plus sine squared. Well, cosine squared plus sine squared was a Pythagorean identity. It was equal to 1. So 8 times that quantity is the same thing as 8 times 1. And therefore, this entire expression ends up just simplifying to 8. Try number 5 and number 6 on your own. Pause the video and see what you get, and then come back and let's check it together. So on something like number 5, 3 minus 3 secant squared of theta. If we factor out 3, you would have 1 minus secant squared of theta. 1 minus secant squared, you might need to flip back and look at your identities here. If we have 1 minus secant squared, well, we have 1 plus tangent squared is secant squared. So if 1 plus tangent squared of theta equals secant squared of theta, how are we going to manipulate that to be 1 minus secant squared? Well, we'd have to subtract secant squared, but then I'd have to move the tangent squared as well. So 1 minus secant squared of theta is going to equal the opposite of tangent squared of theta. So this is actually 3 times the opposite of tangent squared theta. And if we multiply that together, 3 times, this is like a negative 1 here. So 3 times negative 1 is going to be negative 3 tangent squared of theta. A lot of times when we're simplifying, you'll notice that they either simplify to just a single trig function. It might be squared, but there's just one trig function there. Or it might simplify to a number. That's very common. It doesn't happen every time, but it's very common. Number 6. So I see they both have a 9. So if I factor out 9, we would have cotangent squared of x minus cosecant squared of x. Sorry if you hear my dog barking in the background. She wants to come in, but we're going to ignore her for a minute. So again, if you're on a quiz, on a test, you're thinking, well, what was that formula or what was that Pythagorean identity that used both of those? As long as you remember that cosine squared plus sine squared equals 1, I know that cosecant, this is 1 over sine. So if I were to divide both by sine squared, then I'm going to have cotangent squared plus 1 equals cosecant squared. So now let's manipulate this to look like this. So if I want cotangent squared minus cosecant squared, I'm going to take away cosecant squared on both sides. But that also means that I have to take away 1 on both sides. So cotangent squared minus cosecant squared is going to actually equal negative 1. So this would be 9 times negative 1, or negative 9. So how does this help us? If you look at questions 7 and 8, these are going to be a little bit more intense. And what I always tell people during this unit is you have to be comfortable with being uncomfortable, not knowing exactly where to start, but just trying something and seeing what happens. So there's a couple of ways to do every problem. If your neighbor starts one problem one way and you start it a different way, you can still end up with the same answer. For instance, on number 7, one of you might notice that an option is to multiply by cosine squared, to distribute that. So I'm going to do it that way, and then I'm going to show you another way. Cosine squared times 1 is cosine squared, plus cosine squared times tangent squared is cosine squared tangent squared. So I'm looking to simplify this. Well, if we rewrite tangent squared as sine squared over cosine squared, that might help us. So if I keep cosine squared of theta plus cosine squared of theta times, again, tangent is sine squared over cosine squared. Order of operations says we have to do this multiplication before we do this addition. And if I multiply cosine squared times sine squared over cosine squared, the cosine squared factor of the numerator and the denominator will simplify to 1, which means we will have cosine squared of theta plus sine squared of theta. And we know by the Pythagorean identity that this is equal to 1. Now, again, this is just one way to do it. Another way to do it is maybe from the very first step, you noticed 1 plus tangent squared. 1 plus tangent squared, if you go back to your Pythagorean identities, 1 plus tangent squared is secant squared. So that means from the very beginning, maybe you exchanged or you substituted in secant squared here. So it ended up being cosine squared times secant squared. Secant squared, as we know, is 1 over cosine squared. So we're doing cosine squared times 1 over cosine squared. Something over itself simplifies to 1. And 1 times that 1, your answer is 1. Again, I'm going to challenge you. Try number 8 on your own. Let's see how it goes. For me, one possibility is I notice that each term here and here, they each have a sign. So maybe we can factor out the sine of x, which means if I factor that out, the first term here will be sine squared of x. Plus, if we factor sine of x out of this, you would still have cosine squared of x. Well, sine squared plus cosine squared is 1. So we have 1 times the sine of x, which is just the sine of x. The biggest thing for your notes and moving forward is showing work. A lot of this is going to be about, can I follow your steps, how you get from one to the next? And then remembering that, again, your work, maybe this was your work, maybe this was your neighbor's work. If you were to compare at the very beginning, you might convince yourself, oh no, I'm on the wrong path. I'm not going to be able to get the right answer. But it turns out that you don't have to match your neighbor's work in order to get the right answer. So just keep trying, and the more work you put into this, the more you're going to get out of it. And we will continue working on it for practice in class.